Okay, here we are, part 3, page 3. Now, so far, that was a half an hour for 2 parts, 2 pages. I don't think I like our ratio. That's 2 parts, 2 pages. There's 11 pages. So I'm going to pick it up a little bit. So if I'm going a little too fast, just pause it. You can rewind a bit. You have the power. You can't do it in slow mo unless you have some special YouTube controls. I don't have those. So here we go, and we're going to we are going to go and do it. These are all going to be solved, guys. So let's start a fresh page and kick it out. All right, we're knocking them out here. Here we have to solve problem. Find x. You might be able to just look at that and say, oh, what plus 9 makes 19? This one you probably could do in your head, which is cool to do in your head, but it's really good to get used to the process because most of them you can't do in your head. So, and I don't mean you personally, I mean anybody, because they get really, once you get fractions and negative numbers and decimals, it gets a little trickier. So, you might be able to tell that's 10, but let's do it by the steps, which is get the x's on one side, numbers on the other. X is fine on the right there. Some people always like to put their x's on the left. That's okay if you want to do that. But if you do for here, you're going to have to make it negative. It's so happy there being just a positive 1x. So let's keep it there. And the way you move things left and right is by doing the opposite. Plus, let's do minus. And then you get for the grand total of, there's your 10 equals x. We are done. You might hear way in the background is my wife singing upstairs. So that's your extra little plus here. So that's 12. X is 10. And then if you want to check it, put 10 into this spot. And, oh yeah, 10 plus 9, 19. Great. Next. Uh-oh, fractions. No biggie. Now, the way I deal with fractions is to turn them into decimal. I think just generally, sometimes that can be easier. Your teacher might not want you to do that, or whoever your teacher is. In real life, you can do whatever you want. You have a choice. I'm going to go for 0.2x minus 3 equals 1, and then do that same steps. Get x's on one side, numbers on the other. That's usually by adding, subtracting to move stuff around. Poof, these guys go away. And then you get 0.2x equals 4. Divide by, last step is always divide, 99% of the time, problems we got. There you go. These cancel. Great. And you get 1x. So x equals, and what is 4 divided by 0.2? Pray tell. So I know 4 divided by 2 is 2, and that extra point there actually makes it 20. How about that? Alright, if you didn't do it that way, what you do is just keep it 1/5 x. Whoosh, get my eraser out. Same steps. Leave it as it is, but do get x's on one side, numbers on the other. It's the same steps. The difference is we're going to keep the fraction there. Equals 4. And now this guy in front here, how do we get rid of that 1/5 deal? That was supposed to be green. So, and the way is do the opposite. So you can think of it as divide by 1/5. But you know what? What is dividing by a fraction? Better yet, let's just multiply by 5/1. That's the same difference. Same thing as dividing by 1/5. Multiply by the reciprocal, do it to both sides, and then what happens? Boya, boya, get your x, which we want. And then 4 times 5 is 20/1, which is just 20. You get the same place. Same. Okay? 14. Oh no, more fractions. This one's a little more of a pain because if you turn into a decimal like I'd like to do, it's 1/3. It's 0.3333333. When do you stop? I'm just going to take it 2. Maybe 3 is better. I think when it's a repeating decimals, let's just do 3 of them. Why not? Then we're for sure. So, equals 3. Now these you can, that's like terms, x and x. We gotta do a little messing around with subtracting decimals, just do 0.4, take away 0.333, and what you get is 0.067. It's really 0.066666. This is the problem with converting fractions to decimal, is when they're repeating decimals. So, but that's going to work. We're going to be okay with this. And then you got that, and then divide by whatever's in front of the x, and then we'll have x. X equals, and you get x equals 44.776. I'm going to round that. Doesn't say anything about rounding. I'm going to go ahead and just, since again, well, fractions are a little bit, but I am going to round it at least to 44.8. That feels good enough to do that, since we got a whole number 3 over there on the right. So that's the decimal way. Let's do it by the fraction way, which is really going to be the same thing, except you have to mess with fractions. Now I'm looking over here. I've got 2/5 of an x and a minus a third of an x. How are we going to put those together? Oh, you know. Get a common denominator. And since between the 5 on the bottom and the 3 on the bottom, just multiply by each other. He'll be by 3, and do the top by 3. He needs a 5 down here. And now we have 6/15 x minus 5/15 x. That's not too bad. When you subtract them, you get 1/15 x. Cool? And then you do that thing. I want to divide by 1/15, which is the same as multiply by the reciprocal. And holy moly, you get a nicer answer this way. X is equal to 3 times 15, which is 45. The other answer was really close, right? The other answer was 44.8. It's mighty close, but actually this answer is more accurate. I wouldn't take off for that, but just show. I mean, if you did 0.3333, you'd get really close to 45. Probably 44.96. So there you go. So that's what you just got to be careful. If it's a repeating decimal, maybe you want to stick with keeping in fraction form. Again, in real life, how accurate does your measurement have to be? Well, it's according to what you're measuring. So it can make a difference. You know, if it really matters what you're measuring, have to be precise, then if you're doing decimals, take it out 6 places. You know, when you're doing your figuring. Okay. Next. And I didn't mention, you could always check all these to make sure it's good. When you put the 45 in these spots, do you get? The question is, do you get that? I don't know. You have to work it out. 45 here, and then, so 2/5 of 45, that's 18. I'm just doing it, putting over the side. And 1/3 of 45 is 15. Oh yeah, when you take away, that's 3. Yeah, it checks. But, you know, I could do those quick in my head. Sometimes the check takes longer than the problem. So, not a bad idea to check, though, if you have the time. Alright, next. Ooh, it's a little bit bigger. At least there's no fractions. So let's knock this sucker out. So, how do we do this? I'm looking at this. I see all x's and numbers. You know, our goal is x equals, right? So your job is to get rid of the parentheses. So we do that by that thing that you do, because we've got to knock down the parentheses, combine like terms. So this left side definitely needs some work, right? We got to compress that. So we do that by our old trusty distribute. So you get 14x here, minus 7 times 6, 42. Make sure you remember to distribute. And there's a 3x in front here. And then bring down all this stuff. You can't combine the right side because we got numbers and x's. Different stuff. Can't put them together. Keep that straight and you'll do okay on this portion. It's all that chapter 4 stuff. So I'm looking at this and I'm not ready to move stuff left and right yet because not everybody's simplified. generally when you knock down parentheses, check to see if you can combine your like terms, and you can. These guys are like. You like them? Like that. That's 17x minus 42 equals minus 21 minus 4x. There's a lot of writing, but let me move this over. So moving right along, now we're good. Where do you want the x's? Well, there's more on the left than the right, so let's keep them there. Keep the left ones, get that negative 4x, add or subtract to move stuff around. Boom. And what you got is 13x minus 42 equals minus 21. Alright, we got the x's on the left side. Now swing the pendulum the other way. Get the minus 42 plus 42. And those guys knock each other out. Knock yourself out. And then what you get, it's not your final answer yet. It's 13x, I'm running out of room here, equals 21. Ew. Why am I saying ew? Because 13 doesn't go into 21 so nicely, but that's okay. I say ooh because that means there's no way I'm going to check this, because that would be a pain to check. So, what we have here is, I messed up. Stop, hold your horses. You might be saying, but Mr. Pass, you didn't add 4x to 17x, you subtracted. So let me just go back. And the thing about this video thing is I can't edit it. I have to. No, that was right. It's just plus. What I gotta change is not 13. It's 21, silly. At least I caught my mistake. So that's gonna work. Did you catch that? Maybe. I hope so. Hope I didn't mess you up. No, but this way you know and say, wow, the teacher was wrong. I'm right! So there we go. That's much nicer. So, you know, what's interesting is, because the answer came out, you know, it would have been 21/13ths, I checked, that made me check myself. It happens sometimes. Really, in real life, most of the time it doesn't work out nicely. But I think my wife's distracted me with her voice upstairs. She just sings too purty. And there you go. It's nice. It's a nice. There's your answer. That would be okay to check. 3 plus 7 times minus 4. See, I'm sticking ones in here. I don't mind doing that quickly. So then it's 3. Close. This thing keeps popping. I can't control it. So it would be 3 plus 7 times minus 4. 3 plus minus 28. So the left side is negative 25. Let's look at the right side. If I put a 1 over here, oh, looking pretty good. So that's going to be minus 21 minus 4 times 1, which is also minus 25. Yes, Checarunio. So there you go. Last but not least, actually it's not the last one, it's the last of these types. 16 is actually a throwback. It's like the first one we did, number 12. It's easy. This one is easy. So there's a decimal there. Don't let that bother you. So get x on one side, numbers on the other. The x is already on the right side, all with one of them, so just get the 7 on the other side. It is with decimals. If you're using a calculator, you shouldn't have a problem. If you're doing it by hand, make sure you line up the decimal places. This is like a 7.0 if it helps. There's a line for the lineup. So the answer is, it's add, it looks like you're going to add them, but actually it's a plus and a minus, so you're subtracting them. So in reality, if you're doing it by hand, you do that. You got borrow, exchange, 1.1. Positive? Yes, positive. So 1.1 equals x. Now, you wouldn't have had an issue. Again, your calculator is your friend. It's good to be able to do stuff by hand and stuff, but you can always check yourself with your calculator. Alright, there is one more, and here it is. This guy is a problem that keeps popping up, because it's a good problem, I think. And it's this maximal heart rate. That's this guy. The heart rate that for you, safe heart rate, as you get older, you start paying more attention to this stuff, fits this equation. So this is beats per minute. Here's this number. And here's this. This you know, you only have a cent. It's still it's a linear equation, but the rate and initial amount doesn't make as much sense to me. You know, I mean, those aren't so clear where that comes from. It just follows this pattern. You know, the initial amount being 206, and this is beats. This is still beats per minute, and then it's a product of your age. So there's your age is the A in years. So the older you are, the more you're taken away from 206. You know, so your heart can beat faster when you're younger. You can take it. As you get older, your heart's, you know, everything's a little more fragile, not as strong. You know, things get a little less flexible. That's mainly what's going on. So, but not me. I'm Mr. Flexible. So, boom, 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 boom. So, what are we looking for here? The thing about this problem, I've seen this problem in many shapes and forms, is that it's sometimes they give you H, sometimes they give you A. So you just got to make sure you plug in the right one and solve for it. Let's see what this problem calls for. They say if the maximum safe heart rate for a woman is 176 beats per minute, how old she is. So we are trying to find A, and they gave us H. So put that number into the H spot, 176, bring everything down, and we're going to find A by hook or by crook. And then it's just like the other problems we did. So I got my A's over here. Let's leave them, even though they're negative. You could add A's, but let's just leave it there. They're there. It's pretty easy to subtract 206 from both sides. And oh my gosh, it's a negative number. How can that be? Well, because, what do you get, negative 30 here? When you subtract them. And over here, these are gone nicely, and then you get this negative point. It's good, I'm glad this side's negative, because if it was positive, then since we're trying to find an age, it would be kind of weird to be negative years old. That means you haven't been born yet, but you have been. So, and then you just divide by that guy, negative 0.88. See how many times that goes in. So those cancel. And remember, we're finding the age, not the heartbeat. So how old is she? Work that out. And the answer is 34.09 years old. And how old is she? Check your problem. Round to the nearest year. Oh, well, round to the nearest year, you just look right here. And that's 0. Just lop it off. Even though there's a 0.09 here, which would round to 0.1 if they said round to the nearest tenth. But they didn't say that. They said, you don't even have to look at this guy. Don't even look at him. We're looking right at that 0. It doesn't round out. It just drops off. So the answer is A equals 34 years old. And if you are 34 years old, you're max on the, this is just an average thing, 176 beats is okay. It's maximal. You know, that's when they have all the electrodes hooked up to you, and they're like, you're chugging away on the treadmill, and when you hit 176, they'll say, okay, that's your maximal heart rate. If it starts going much faster than that, they're going to keep an eye on you. All right, that's it for page 3. Was that faster? No, but we're covering ground. Thank you very much. I'll see you at part 4.